Hello. Good afternoon, everyone. Can everyone hear me? I hope the sound is good. Okay, awesome. Okay, so good afternoon, everyone. Today we are going to be talking about software engineering, and I am your host. My name is Tavonga, but you can just call me Tav. And today we're going to be discussing the four pillars of object-oriented programming. So, our goals for today are to learn obviously the four pillars, but also to learn why they're important and learn how to properly apply them. Before we begin, please note a few things. Firstly, the concepts in this presentation are not language dependent. So, any sort of language or framework that applies the object oriented paradigm will also apply these principles in some way or some fashion. And however, I will be using the Java language for the demos because if I did like use every single language, then we'd be here all day. But the pillars that I present are all equally important and linked. So the order that I do this in is not necessarily indicating any preference or importance. This is just the way that I identify it as what might be the easiest way to understand them, as this is just to serve as an intro. And also, I am assuming a basic knowledge of programming in the object oriented paradigm, specifically that you know what variables are and the types of variables that we have, and what classes are, what objects are, and what methods are. Okay, so on to the first pillar. So I'm going to start off with inheritance. And inheritance is defined as the process that enables one class to acquire the methods and variables of another class. And we refer to the class whose properties are inherited from as the parent class. And depending on who you're talking to or what language you're working with, it can also be called the superclass or the base class. And the class that is inheriting the properties is called the child class. And again, depending who you're talking to, can also be called the subclass or the derived class. And in Java, to inherit from another class, we use the extends keyword. And the subclass through this will inherit all the superclass non-private variables and methods. In this diagram here, I just wanted to show you how inheritance works from a visual perspective. So as you can see at the top there, we have the class vehicle. And vehicle has the methods, fuel amount, which just gets us how much fuel is left in the vehicle. The capacity, which tells us what this vehicle carries. And apply brakes, which simply slows down the vehicle. And as you can see down there, we have three other classes which are inheriting from this vehicle class. We have bus, car, and truck. And the reason why I specifically wanted to show it this way is the thing about inheritance is I want you to understand that it is a one-way relationship, or at the very least in the context of Java, it is a one-way relationship. And by that, all I mean is that a bus is a type of vehicle, a car is a type of vehicle, and a truck is a type of vehicle. But a vehicle isn't necessarily always a bus, always a car, always a truck. It can be any one of those. So that is simply what I mean when I say it is a one-way relationship. And to demonstrate this, I actually just want to show you what inheritance looks like in person. So I'm just going to try. Hello? Okay, sorry about that. Technical difficulties for a moment. I'm gonna try to enable screen sharing now. Hopefully it works out. And okay, just to confirm, can everyone hear me now? Like, is the sound fine? Okay, awesome. Cool. So I'm going to go to my IDE, and also I'm going to go to my IDE, and we're going to demonstrate some inheritance. So I'm just going to zoom in here so you guys can see a bit better. And as you can see, we have here the vehicle class that I was talking about. And just to get you familiar with what's happening, we have our variables here. And basically, we have mass, drag, fuel, velocity, capacity, and color. And as you can see, this is just our default constructor that will just get called whenever we make a vehicle. And these are our other methods that were mentioned before: getting the fuel amount, getting the capacity, apply brakes, and I made an extra one, accelerate. So to show how inheritance works, I'm just going to use the car class as an example. So to connect car to vehicle, we use the extends keyword, as I mentioned previously. So all we have to do is just say extends, and we say vehicle. And through this, we can now see that this car class is inheriting from vehicle. And that basically means it has access to all the public members that are inside of this class. So all the public variables and all the public methods are accessible in this car class now. So if I say, um, oh, actually, it's something I needed to mention, like that I just remembered now. So you can see here we have a default constructor for the vehicle class, right? So one of the things that needs to be mentioned is that constructors are not inherited by this subclass, this child class here. But this constructor is still called whenever we make an instance of the car class. So to show that in action, I'm just gonna, inside this car class here, I'm just gonna initialize by printing out to the console. I'm just going to type out a simple message that says, "Hi, I'm a car." Okay. And I'm going to go to my main method here, and we're going to initialize a new vehicle. So let's call it a Ferrari. Why not? It was new car. And this should call our constructor for vehicle and our constructor for car as well. So I'm just going to compile the code here, and we should see our output. Wait, sorry. Yeah, it's just building the code. Just give it a moment. Okay, there we go. So as you can see here, the vehicle has been made. This message is printed out in the vehicle class. So this is the default constructor for the vehicle class. But hi, I am a car is in the car class. So you can see that both methods and both messages have been printed to the console. And that's basically because this constructor is called whenever we make a new instance of a car. And also another thing to note about this this line of code here is that because a car is a type of vehicle, we can actually instantiate we can actually declare it as a Ferrari as a vehicle, but then give it a value of a car. So we can actually do the same with the truck here as well. If I just say extends vehicle, then I will be able to do the same thing and just call this a truck instead. and it'll work perfectly fine. So that's basically all inheritance does for us. It allows us to inherit from another class, much like how, for example, to put it into another context, much like how as a child you would inherit some of the DNA and some of the characteristics of your parent. And here I can just say Ferrari dot, and then you'll see that I can accelerate, apply brakes, and get the capacity. So all the public methods and variables are there. Okay, so that's basically all there is to inheritance. And going back to our presentation. Okay, so moving on, we have the next pillar, which is polymorphism. So polymorphism occurs when there is a hierarchy of classes related to each other through inheritance. So all I mean when I say this is just that inheritance is kind of a prerequisite for polymorphism to occur. And so without inheritance, we won't necessarily have polymorphism. And a call to a method will cause a different implementation to be executed depending on the type of object invoking that method. And again, this is best shown by actually like demoing it. So I'm just going to pop back into my IDE here and show you guys how polymorphism works. So if you remember, we have our car here and it has our default constructor. And so I'm just going to quickly show you the get capacity method, which should return to us our capacity. And capacity, as you can see here, just tells us what this vehicle is able to carry. And right now, it just tells us that it's a vehicle and it can carry anything. So that might not necessarily be true for a Ferrari. So we're going to change that in our car class. And we're going to say get capacity, yeah. And we're just going to say that it is, I am a car, I carry people. And that's essentially our cars get capacity method. So if I go back here and I make this a car again, and then I print out to the console the system, yeah, the message of the get capacity method, we should get yeah, there we go. I'm just gonna compile my code real quick. It's building over here. Yeah, so as I was saying, we should get that this Ferrari carries people and not just anything. And okay, let me just zoom in on the console output there so you can see. Yeah, as you can see here, this is a car and it carries people. But if I were to just say this was a vehicle instead of a car, then it would change its implementation and basically tell us that it is a car, it is a vehicle and it can carry anything over here. Yeah. And basically what I'm just trying to show you with polymorphism is that because we already have inheritance as our prerequisite, so we already established inheritance by using this extends keyword, then how our subclasses behave and interact can basically change based on its implementation. So the way that the car class has implemented get capacity is different from how the vehicle class has implemented get capacity. And that's essentially how polymorphism works. Cool. Yeah, so that is essentially polymorphism. So far we've covered inheritance and polymorphism, and I hope we can understand that these basically are Wait, sorry, I'm just reading the chat. Are people still having like sound issues? Like, can anyone hear me? Is everything okay? Okay, awesome. I'm gonna trust you there. Okay, awesome. Um, okay, so as I was saying, the we've covered inheritance and polymorphism, and essentially polymorphism is kind of dependent on inheritance, and the usefulness of these two pillars are essentially code reuse and also the ability to essentially um, be able to change certain aspects of your code. So, for example, in a subclass, you can change how that implementation works without necessarily having to change all your code. And that is essentially the aspects that you need to kind of like grasp to fully understand inheritance and polymorphism. And moving on to the next pillar. Now, this is where it starts to get a bit more complicated, but we're going to go through it together. And yeah, so abstraction. Abstraction is the process of showing only the essential or necessary features of an object so that you hide the internal implementation of it. And the concept of abstraction is basically that you only focus on what you need to worry about or what the essential aspects are, instead of rather focusing or being distracted by the specific characteristics or implementation details of any one particular object or example. And a real world example of this would be the car. So as we've been dealing with car classes and car objects. You can think of for those people who aren't necessarily um, into cars that much. You think of a car as something that just serves a purpose. So it gives you transportation. You don't necessarily worry about how combustion works, how the brakes are applied, or how like how the oil is used or lubricated or anything like that. You just really have the overall abstracted concept of a car, which that it gets you from point A to point B. And that is essentially the overview of what abstraction is. And to give you another example of this, think of a TV remote. So when you look at a remote, you see the buttons, right? So you see like a power button, you see the volume up and down buttons, and you see the buttons to change the channel. And when you press these buttons, you're basically using the abstracted concept of a remote. You're not necessarily worrying about how the remote is working. So how the signal is transported from the button press to the controller in the remote, and how the controller in the remote sends a signal to your TV, and how the TV interprets that signal. You're not worrying about any of that. You're really just dealing with the abstracted concept of a remote. And in Java, we achieve abstraction through abstract classes and interfaces. And an abstract class is basically a class that can't be instantiated. So you must inherit from this class to make an object from this class. And essentially, this ensures that when you make an abstract class, that the whenever someone wants to use your class, essentially they have to inherit from that and use it in their own code. So I'll show you an example of this once I'm done with this slide. But basically, I also just want to explain that abstract methods methods can also be abstract, and essentially these are just methods without an implementation. So for example, if you remember in my get capacity method that I showed you just now, it should return to us a string basically telling us what it carries. So whether it can carry anything or whether it carries people. And essentially, the abstract method is just a definition of a method. So you'd say something like public string get capacity, but you wouldn't actually open up the braces and like specify the code of how this method behaves. So you wouldn't actually say return a string or anything. You're basically just saying that this is a method that exists, but the actual implementation is up to the child class, which inherits this abstract class. And in this way, some methods in the class can be implemented while others are not. And the other way that we achieve abstraction is through interfaces. And essentially, an interface is just a completely abstract class. So essentially, you cannot instantiate it at all, and it only contains definitions of methods. So the difference is that with an abstract class here, we can actually declare some of the methods as abstract and some of the methods as actual methods with code that we've written to actually implement certain things. And I'll show you an example of that too. But with interfaces, you can only contain static final variables. And if you're not familiar with those keywords, basically static just means that you don't necessarily have to have an instance of that object or of that class existing in order to call that a variable or method. And I'll again show you another example of this. But essentially, I just need you to understand that the variables inside of an interface are static and final. And final essentially just means once you've declared that variable, you cannot change it at all. And again, interfaces cannot contain constructors because obviously they can be instantiated. And finally, a class can implement many numerous interfaces. And we're going to jump back to our code real quick so that I can show you all of this in action. Just waiting for the screen to share. Oh yeah, there we go. So over here, I'm going to start showing abstraction by, okay, let's start off with interfaces. So as you can see here, I have an interface called engine for my vehicle, right? And all engine does is have a declaration for these two methods here. So we have essentially whenever something implements the engine interface, we know that it needs to have a method for applying brakes and a method for accelerating. And this is just a variable initial velocity, which will always be 0. And I'm going to now implement this engine interface in the vehicle class. So the way that we do this is basically just use the keyword implements, and we just see what interface we want to implement. And in this case, it is engine. So as you can see, engine has basically specified that we have to have apply brakes and accelerate. So right now, everything is fine because I have these methods here with me, apply brakes and accelerate. But I'm just going to quickly show you here in my IDE. If you can't read this text, it just says implements method in engine. So it's basically just telling us that this is an interface implemented method. So if I were to take these out right now, we would actually get a compile error because it's saying that this class must either be declared abstract or implement the method apply brakes. So in this way, an interface basically just strictly demands that whatever behavior that this interface is expected to have must be implemented by whatever class is implementing that interface. So if we were to try to compile this code, it would actually just give us a compile error because we can't compile it because vehicle needs to implement these methods inside of engine. So I'm just going to put my code back in there. And essentially, that's how interfaces work. And I'm just going to show you here, the accelerate method. So this is essentially my example of how I wanted to show you how abstraction works. And essentially what's happening here is that when we accelerate, so think of how like when you drive an actual car, when you accelerate, you don't worry about what's happening. Like you don't worry about drag, you don't worry about mass, you don't worry about wind resistance and all that. All you really have to deal with is the abstracted concept of the gas pedal and how it affects your car. So like how much speed you're gaining. So, keeping your car under the speed limit. So if you're accelerating at 60 kilometers per hour, then you want to keep it at 60 kilometers per hour if you're in a zone that the max speed limit is 60 kilometers per hour. That's all you really have to worry about. You don't worry about the actual implementation. And bringing it back to a programming context, we can see here that I have my accelerate methods. And please just suspend your belief in reality for a moment, and let's pretend that this is how physics works. Essentially, whenever we accelerate, we're increasing our velocity by this formula here. And all I'm just saying is that we're going to say, okay, like let's say 10 kilometers plus the 100 minus mass divided by drag. And I'm just going to absolute that just to make sure it's always a positive number, because whenever we accelerate, we always need to be increasing the velocity, right? So when we come here to our main method, so we'll see that so our Ferrari, all we have to do is just accelerate, right? And in that way, we don't actually have to worry about, okay, let's say you're making a game or something. You don't actually have to worry about, okay, I have my Ferrari object and I want it to accelerate, but how do I do acceleration? Do I have to now like get the drag? Do I have to get the wind resistance, and do I have to like come up with a formula for that and like manipulate those values to get acceleration? But essentially, this is what abstraction does for us. We're abstracting away the concerns of that, and we're only having to deal with this method. So we only just need to know that this method exists and what effect it will have on our Ferrari vehicle object. And that is essentially how abstraction works in the context of interfaces. And I just want to quickly show you as well the abstract class example. Oh yeah, as well. Actually, I need to show you how this works as well. So this is static and final. And remember what I said about static is just you don't need to have an instance of that object. So for example, when you say math dot power, right? Or math dot, oh, actually I can't call that method in here because it's an interface, but let me just do it here. So when you say something like math dot, let's say power. So when you want to square a number, so you say 2 to the power of 2, right? You don't actually have to make an object called math, I don't know, calc equals new math. That is essentially what static means. When something is static, so this power method here is static, you don't have to actually create an object of the math class because it is declared as static. You just have to simply call the class and the method that you want to get access to. And in that way, this interface variable here is static, so we don't actually have to instantiate it because interfaces can't be instantiated. That's why it's static. And it is final, and that just means that once we have declared this, it can't ever be changed in code. And that's essentially what that's essentially how variables work in interfaces. So for the most part, proper coding conventions would say you probably shouldn't put variables inside of an interface. And I would like really agree with that. Like if you can absolutely avoid putting variables in interfaces, they, for the most part, they have no business being there. Like if you want variables, then you should be implementing them or declaring them in the classes that implement these interfaces, or in the child classes that inherit from these super classes. And jumping over back to my vehicle class, I'm just going to show you how abstract works. And essentially, we just do it with this keyword abstract. And all that means now is that we cannot instantiate this vehicle anymore. So if you come here, you'll see that it's throwing me a compile time error. So vehicle is abstract and cannot be instantiated. That's what the error message says here. And essentially, this just means that the only way we can get access to vehicle and all its methods and variables and everything else is that we have to inherit from it. So we've already done it here. As you can see, that car is inheriting from vehicle. So now we have to change the Ferrari to a car. and everything will be good again. We now have access to everything that a Ferrari can do. We can accelerate, we can get the capacity, we can anything that's essentially public, we can now do. And just to show you how strict these rules are, you'll see here I have a string for color, and it is private, right? So if I try to access the color of this Ferrari, you'll see that you'll see that it won't let me, and my IDE is actually showing me an error here saying color has private access. And I just want to like really cement it in your mind that the vehicle, or rather the implementation, when you're inheriting or implementing interfaces, that anything that's private will not be inherited. So the only thing that will be inherited are public and protected. And yeah, that is essentially abstraction. So far we have covered the pillars of inheritance, polymorphism, and abstraction. And at this point in time, I hope you're beginning to understand the links between these pillars. They all kind of go hand in hand, and they make coding for you as a programmer a bit easier because you don't necessarily have to worry about specific implementation details, and you can make your code a bit more modular as well. You can just take what you need and throw away the rest. And basically that is abstraction. And moving on to the final pillar, we have encapsulation. This is also a bit of another a difficult one to grasp, or at least I had a bit of trouble personally grasping it when I started learning programming. And essentially, okay, wait, sorry, I just looked at the questions now. Okay, so I just got a question. What is the void keyword for? Just in case this hasn't been answered already, basically the void keyword just means that the return type is nothing. So for example, how my get capacity method was of type string, that means that whenever I say vehicle.get capacity, it returns me a string telling me what it carries, right? So the void method, all it does is just say, okay, this method doesn't return anything. It just performs an action, and that's it. So an example would be the accelerate methods. I don't need it to necessarily return me the velocity of the vehicle after it has accelerated. All I needed to do is just to accelerate. So I don't actually need a return type. And that's basically all that void does. Okay, so encapsulation. Encapsulation is ensuring that the implementation details are not visible to users. So if you remember here, how I defined abstraction is the process of showing only essential or necessary features. Then encapsulation is kind of the rule, the how we enforce that abstraction. So abstraction is just the concept. It's just the you dealing with the overview or the concept of what that object is. And encapsulation is how we go about abstracting something. And essentially, the variables of a class will be hidden from other classes and are only accessible through the methods of the class that you defined. And this technique is called data hiding. And essentially, the main benefits of encapsulation in general is that you control the way that the data is accessed or modified in your class. And this also makes it more flexible and easier to change your code. And you also have the ability to change one part of the code without affecting other parts. So let me just show you here how encapsulation works together hand in hand with abstraction. Okay, so here we have our vehicle class, right? And it's an abstract class. So I just want to quickly show you, I'm just going to delete that our Ferrari class, we actually have access to the velocity. So I can set the velocity to 1 million if I want to right now. And for obvious reasons, that's a very bad thing, because I shouldn't, um, from a programmer standpoint, I shouldn't be able to manipulate the internals of how this Ferrari or this car class works. So to control that, what I can do is then make this velocity variable here. I can make it private, and that will essentially prevent me from accessing the yeah that will eventually that will essentially prevent me from accessing this private variable. And the only way that I can interact with the velocity of this Ferrari is by calling my, or either my accelerate method or my apply brakes method. So this will essentially increase my velocity and this will decrease my velocity, right? As you can see here, I have these two methods here. The accelerate will increase it by this very broken formula here, and the apply brakes will essentially just stop the car. And that is essentially what encapsulation does. We are encapsulating the internals of our class, so we're making it inaccessible to anything outside of our vehicle class, and we're controlling how people will interact with our vehicle by defining these two methods here, apply brakes and accelerate. And essentially, the pattern to achieve encapsulation is to just essentially make private variables and public methods. There are other types of pattern and stuff, but we won't like get into that too much, because this is essentially the most prevalent pattern and the one that you will be using the most. You just say something is private, and the only way that you can manipulate it is by declaring a public method. And that ensures that for both security and also just like people not messing up your code, that the implementation of your class is kept encapsulated, and people will interact with it how you want them to interact with it. And also, just a throwback to the previous question, basically this is what void is doing. We're just saying, I don't want this method to return any type of value. I just want it to perform this action, and then it can exit. Like, I don't need it to like return me an int or string or anything like that. And that is essentially encapsulation. We're just simply controlling how other programmers will interact with our code. And yeah, that is essentially the fourth pillar. So just to do a quick recap, we've covered all four pillars: inheritance, polymorphism, abstraction, and encapsulation. And we've seen how these four pillars work together in tandem, how some of them are dependent on others, and that they all work in tandem to make uh, our lives easier as programmers, to create better code, more efficient code, and more secure code, and also just to make things easier as programmers who use other people's code in a very wholesome way, so that we don't break their code and we can also integrate it into our own code seamlessly. And that is essentially what the four pillars are here for. They are guiding principles that help us create better code. And yeah, that is it. You have made it to the end of my presentation. Congratulations. If you have any questions, please go ahead and ask them, and I will answer the best that I can. Wow, thank you. You are all very welcome. Glad to have you here. I hope this was able to give you a bit more clarification on the four pillars and their usefulness. Please do keep in mind, though, this was mostly an intro. There is a lot of depth to these topics, and I would recommend just like doing a bit of pleasure reading on the ones that interest you. But for the most part, these are the important aspects to understand about them, and I recommend applying them in your programming as soon as possible. Okay, so I'm gonna upload these so that you guys can have access to these slides. And yeah, what I can also do is just create a quick paste bin of all the code that I have made as it is now, so that you can also just play around with it and be able to essentially just cement the topics for yourself so you can see how they work. But yeah, I'm gonna assume that there are no further questions, and I'm gonna end the presentation here. Thank you all for joining me this afternoon. I hope you all learned something. And yeah, that is me. Cheers, everyone.